Hi, my name is Daniel Hastings and I'm undertaking a higher degree by research at the University of Queensland on the incorporating of ESG factors in strategic mine planning. ESG issues in mining is becoming more and more important, not just for ESG outcomes themselves, but also for the potential future impact on supply and the ensuing ramifications on society. Industry and business know that ESG factors in mining is a problem and it's only getting bigger. It is suggested that current strategic mine planning systems are unable to adequately include ESG factors, which presents a significant problem. Additional to the less than optimal ESG outcomes from operations, if inclusion of ESG factors in planning systems is not addressed, the resulting lack of ability to provide development options for projects that minimises negative ESG outcomes may lead to a supply-side crunch that will result in the rapid development of many projects that have significant ESG issues. Mining is seen by a large portion of society as environmentally and socially irresponsible and destructive. We accept that mining activities impact the environment and the community in negative ways, but it is also important to acknowledge that mining is a fundamental requirement for our civilization and has many positive impacts. Daniel Franks captured this sentiment when he wrote that with every transaction, society affirms its reliance and its lust for the products of the mineral sector, but with every word it restates its displeasure at the way that these products were produced. Nothing has really changed in a meaningful way since these shortcomings have been identified. Mining is trying to respond, but it is suggested that they are really struggling to include ESG factors in current planning practices. Too often, mining discussions are simplified into a choice between mining or protecting the environment and community. The mining industry must endeavour to show that this is not an or statement, it needs to be an and statement. Current approaches to ESG issues in mining is reactive. Projects are designed, then appraised for ESG issues. We need to be proactive in development design. A large dislocation exists between intent and outcome when assessing ESG issues in mining development options. These current analyses occur at the beginning of the project and at the end, but not throughout the life of the project, and are generally not included in strategic planning, certainly not in any significantly integrated way. This reactive view also precludes the idea that improved ESG outcomes are possible while maintaining corporate economic requirements through better strategic planning systems that seek to include ESG issues. So why is there no robust and comprehensive framework for this to occur? Well, at its core, inputs are the problem for current mine planning systems. Quantitative inputs are a lot easier to handle than qualitative inputs, and ESG issues quite often are qualitative in nature. Strategic mine planning involves primarily pit and schedule optimizations that solve to an objective function, which is almost exclusively NPV maximisation. So using current strategic planning systems, qualitative ESG variables need to be converted to economic values. Currently, willingness to pay is the primary method for deriving quantitative economic values for qualitative ESG variables. This method has been around for over 55 years, and as of 2011, more than 7,500 contingent valuation studies and papers had been undertaken. It does, however, have many shortcomings and biases. Who is doing the assessment and who is gaining the benefits? The challenge is to get both quantitative and qualitative ESG variables into the strategic mine planning framework. To achieve this, there must necessarily be a linkage between mining activities, which can be measured and forecast as part of the mine development plan, and qualitative ESG outcomes. The key will be to show that linkages can be made between quantitative mine development outputs and qualitative responses. So as to avoid issues with economic valuation, the aim is to provide a framework that utilises non-economic metrics that can then be included in scenario analysis. Since this methodology involves both financial and non-financial metrics, The current optimization processes cannot be the only ones used. Additional processes will need to be added to the overall planning system. If the objective function of the optimization process is changed from maximizing NPV, then the optimization becomes flawed. If multiple objective functions are undertaken, then this can cause conflict with which results in poorer performance. You can mix financial metrics and probability, but mixing financial and non-financial metrics in the objective function will result in opaque outcomes. Apart from discount rate, risk is not typically incorporated into NPV in mining applications. Work on this is currently being done, however the incorporation of qualitative risk presents additional issues. What could an ESG cognizant planning system look like? The current strategic planning process is shown in orange. Mining inputs comprise of various models, design criteria, and financial metrics. Some of these inputs flow directly to the optimization processes, such as geotechnical and haulage models. However, a lot of the information is used to develop a geomet model that carries data required to determine ranking metrics, i.e. cash flow grades. The optimization process commonly comprises of pit optimizations using an LG or pseudoflow algorithm to determine the optimal pit shell. Mine design processes follow when mine stage and other detailed design is done. This enables the creation of material bins to be calculated for use in the schedule optimization. Schedule optimization, normally using mixed integer linear programming, dynamic programming, or both, can then be done to derive the optimal period schedule based on the objective function, that being maximization of NPV. Most normally, quantitative ESG inputs can be included in this process. At this stage, these ESG inputs are pretty much only waste management costs. Once the schedule optimization is complete, the output is passed to a corporate financial model to enable inclusion of financial activities such as depreciation and amortization, company taxes, movements in stock and working capital, and other such things. One possible solution for inclusion of ESG variables is shown in green. That is the creation of a geo-ESG model and system dynamics modeling. The geo-ESG model will carry any quantitative and possibly some qualitative information that can be estimated and tied back to the underlying geological model. These variables will be carried through the current optimization process, but not necessarily inform the current process. This is done so as to provide the ESG variables in period format that can then be fed to the system dynamics model from both the financial model and directly from the schedule optimization. ESG variables from the geo-ESG model will also likely be input directly to the system dynamics model. The system dynamics model will provide the framework by which quantitative period variables are linked to qualitative variables over time. The framework will provide for the use of modules that can be built for any ESG variable of interest or ESG variable determined to be impacted by the mining development. These modules will be different for each operation as a result of things such as mine geographic location, commodity type, local, regional and national community makeup, cultural considerations, surrounding natural environment, etc. These variables and linkages can be mapped temporally in the system dynamics model, including well beyond the actual life of mine. The ESG variable period output data could be combined into a single metric like NPV is, or other metrics could include the schedule maximum or some inflated or discounted outcome. These outputs, whatever form they ultimately take, can then be used to undertake ESG cognizant scenario analysis. If the processes are set up correctly, it becomes amenable to a brute force assault, whereby a very large number of scenarios can be executed in a relatively short time frame to build a database of possible outcomes. Scenario analysis can then be undertaken. Ideally, identification of scenario pairs that have similar economic outcomes but vastly different ESG outcomes would be done. Drilling down into the data would allow for determining which development options impact the ESG outcome variance most. Decision makers would then be able to take ESG impacts into consideration when determining development options by being better informed of the likely ESG outcomes of each scenario. Thank you.